I can proceed. Okay. Good evening, sir, once again. My name is Lawal, and you're welcome to this presentation. So before I go into the presentation proper, I just want to give you more like a background information and a knowledge about the reason of this presentation. So in the last 5 years, I was actually working at different microfinance bank, and the main problem that we have in the sector is whether a loan will be repaid or not. So meaning we want to know whether this potential customer is going to default in the loan repayment or not. And there are so many factors that could cause this thing. We have the quantitative parts and the qualitative parts. So the quantitative part has to do with where we gather data either manually or automatically. So in the microfinance sector, we have an Excel sheet whereby we collect all of this data and we'll slot it into that model to see the structure of the business. Then for the qualitative part is just for the loan officer, right? To just see whether this person can actually take loan or not. But the problem there is at the end, you still find out that this customer, upon all of this analysis, upon all of this credit committee, you still find out that this customer still went ahead and still default, right? Another bottleneck with this process is this process literally takes between 3 to 7 days before a loan is being processed. Thereby, there could be diversion of funds and some other stuff. So this was what actually prompted this analysis. Yeah, so but unfortunately, I was unable to get a Nigerian-based data set. So I actually have to use the home credits data set, which I got from Kaggle, right? So let me open the EDA. The EDA is the exploratory data analysis. So on this my notebook, I have about 8 notebooks. I have the feature engineering, the baseline model, the SG boost with the sharp, I have the anomaly detection, the daily explanatory, the smooth experiment, and the model studio dashboard. So quickly, let me talk about the EDA. So in this EDA is just to explore what we have in the home credits data set. So in this home credit data set, we have 307,511 rows with 112 columns. So out of these columns, out of this data set, we have our target variable. The target variable is those that default and those that did not default. Just like I said, our main aim is to predict whether a potential customer will default or not. So from this data set, we have 0 representing those that did not default and 1 representing those that default. And we'll find out that 8.07% of the data set actually went default, while the 92% of the data set did not default. Looking at this data set, we already see that there's a class imbalance in this data set. So it means that accuracy alone will not work for us because if you go ahead and build a model that will just predict and using accuracy to actually determine our metrics, we're already failing because the data set is already telling us 92% will not default. So we're going to use other methods. So we're going to use other metrics like AUC or ROC. AUC means area under the curve. And we're going to use also and the F1 score to actually evaluate our metrics. We're going to apply the smooth or class weight imbalance during modeling so that we can find a way to balance this data set. Then we also use the precision and recall for our analysis also. So looking at this data set, so all these parts is just trying to tell us the overview of the data set. So in that same data set, we have some columns that we don't need. We also have some columns that are empty column. So we actually deal with all of these data sets. And this chart here is trying to tell us the loan distribution across people that actually defaulted against those that didn't default. And on this other chart here, I'm having those like default contract type. So we have different contract type. We have those that actually collect cash loan and those that are on the revolving loan. All right. So just like I said, we remove those columns and we also look at other exploratory analysis. Like we also look at the gender. So we want to see, does gender actually affects whether you're going to default or not. And looking at this now, we can see that the gender variation on the default level is not really that much. Then looking at the age distribution. So based on the age distribution, we can see that people around the age of 20, 25 down to 40 actually are on the default side, while people are above 40 do not really default like that compared to people around 25 to 40 years of age. Okay, so we also have the income distribution, right? So we want to know, is it that the higher you earn, the less you default? So I mean, if you look at this now, people that actually earn more are those that did not really default. And looking at these charts, then we're looking at um, the default rate by your income type. So is it that the students, is it businessman? So we look at it, we see that people that are on maternity leave, people that are unemployed, and some that are actually working are those that actually contributed to the default. So basically, this is just what the exploratory analysis is trying to tell us. So looking at also the credit to income ratio. So we want to see uh, the more income you have, does it have an impact on whether you are going to default or not. Okay. Then lastly, we also have the annuity to income ratio. So once you check your debt burden, does it actually affect uh, your default? So that's that on the exploratory analysis. So quickly, let me take us to the feature engineering. So on this feature engineering is where we actually extract the columns that we're going to need for our analysis, drop the missing column, okay? Then we undo the remaining missing value, then do some sort of encoding categorical variable. And lastly, we want to save this data set so that we can use it for our model. So basically, that is what we actually carried out on this feature engineering. So at the end of everything, the 122 column, we actually reduced them to about 88 column, and we needed to add another extra column. So the extra column that we added is we want to see the debt to income ratio, right? So once you check your debts across your income, does it really how what is the effects it has? So for example, if my debt is 1 million and my income is 10 million, so that ratio is actually still fine because I can easily pay back my loan without having to stress myself. So basically, this is what this particular notebook is trying to actually explain to us. Now, let me move to the next notebook. And the next notebook is the baseline model. The baseline model is the default model that is being used by most fintech and most microfinance, which is the logistic regression. And looking at the logistic regression, the reason why most banks actually use this is because of it. It's actually easy to interpret. It is fast, and it's actually more like the industry standard, more like the traditional credit scoring model that is being used by majority um, of the bank. All right. So looking at the logistic regression, we can see that it's telling us that 74%, that is 74% of the time you're going to see a default, right? So it's currently ranking a defaulter above a non-default. So each time, strength the accuracy of this model is 74%. That is what uh, the logistic regression is trying to tell us. However, once we try other model, whether it's going to improve above the traditional method. So that is why we want to use other models like SGBoost to actually see if there's going to be an improvement above the logistic regression model. Okay, so we also have the confusion matrix. So the confusion matrix here is just trying to tell us that, oh, out of the total number of people, we have 39,132 that did not defaulted, and we also have the false positive on this side. And for the people that did not default, we have 1,625, and we have the false negative, right? which is 3,340. Okay, so the correctly approved people that we can go ahead with to give them loan is 39,132. That is what is actually catching. But if you look at the ones that it actually missed, so it's trying to tell us that it missed about 32.7%. So on this part, this actually has to do with the financial institutes conditions. So if they feel, are we actually losing more money based on this missed part, 32.7%. So if it's something they can go with, then they can actually leave it that way or look at it at the other way around. All right, so for the logistic regression, like I said, we have 74%. That is catching it each time. And we have the F1 score, which is 25.98. The precision is 16%, while the recall is 67%. So it's trying to tell us that out of every 100 defaults, that is 67 are actually correctly flagged, while 33% are actually flagged incorrectly. So that is what the recall is trying to tell us. So now we we now want to check our SG boost so that we see if our SG boost actually the model is actually better than this 74% that the logistic regression is trying to tell us. Okay, so um, okay, so we are still on the logistic regression. So this chart here is just trying to actually tell us the most important features based on our data set, right? So we can see that the 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 goods price, the credit amount, the credit bureau. So all of these are actually contributing. They are like the predictive power of our prediction. So the red part is trying to tell us that this will actually increase default, while the blue part is trying to tell us that this will actually decrease default. So if the customer is having the this more of the red part, that means it's going to actually increase the default. Now, this amount of credit means the amount we're actually giving out. So if the amount is more, then that means the bank is liable to more risk. So talking about the credit bureau, so if the credit bureau is, if the score is very high, then that means the customer would not default. So we can see all of this in this data set. All right. So let me just go to the next let me go to the next notebook, which is now the SG Boost. So for the SG Boost, like I said, so we are trying to compare uh, what we have in the logistic regression, which is the traditional method, to the SG Boost. So after building the model for the SG Boost and putting certain criteria, right? We ensure that the random state is still 42 and the stratify. We're trying to ensure that it's whatever we are putting on this side is also the same thing on the other side. So based on this, so we we note that the SG boost actually increase coming, where is it down? Okay, good. So we noticed that it's actually improved by 1.95%, which is actually a good one. So it means that with SG Boost, our model can actually predict with 76.79% that, oh, the probability that this person will default is so it's, which is significantly an improvement for our data set. So it shows that it's still a better model compared to the logistic regression. Then coming down to the confusion matrix, we can see that it's actually called 65% bad loan, and it means 34.2% of the bad loan. Just like I said earlier, depending on the bank standard, if they feel that missing 34.2 would not have an adverse effect on their profitability, they can actually tone it down or leave it that same way. However, we know that we cannot just tell a customer that, oh, you did not meet up with this criteria based on CBN rules and regulations. So you must actually explain why you are not giving a loan to a customer. So that is the reason why we are using the sharp summary. So the sharp summary is going to tell us why a loan is being approved or why a loan is being disapproved to each customer. So based on this chart, so it's telling us that if you look at this chart here, the red color is indicating very high, while the blue color is indicating very low features, right? So we can see that the the score of their credit bureau is actually a predictive power. The credit term, that is, how long are we giving this loan? Is it 5 years? Is it 6 years? Is it 3 years? Because the longer the loan tenure, the more the probability of default. So all of these encompasses together are actually a predictive power in our analysis. so so going by the sharp waterfall, so why this uh, borrower was actually flagged high risk. So we can see that this is trying to tell us that 93% is for the credit bureau score, and we have it like that across the different features that we have on our data sets. So this part is just trying to show the correlation between the sharp and um, the the credit bureau score. Okay. Okay. So now there is something that that was actually carried out. So initially, the analysis was carried out with the gender column and also without the gender column. So gender is something that we need to be careful when we are doing our analysis. We don't want to be gender biased such that we don't want to have this bias that the female gender tends to use more money better than the male gender. But from this analysis, it shows that the gender has no significant difference in our analysis. Looking at the AUCRC analysis, is still with the gender, we have 76.79. That is, it's catching default by 76.79. Without the gender column being inclusive, we have 76.64. So there is no significant difference. So we can't say that, oh, whether you are a male gender or a female gender, you will actually default. Looking at the recall also, we have 65.8% with the gender and 65.26 without the gender. Okay, so let me take us to the anomaly detection. So we actually look at another model. So we also look at other models like the SVM and the isolation forest to actually see if if they will actually perform much more better than the uh, SG boost. But after training this model, it was noted that they actually perform worse. So looking at the isolation forest is showing it's catching the default with 52.13%, and the recall is showing 0.099. So it's catching 92% and is missing 90.8. So what this is trying to tell us that majority of the bank will actually be missing a lot of money because it's actually catching default with 9.2. So in essence, what this is trying to tell us is we we cannot treat um, loan defaults as an anomaly situation, because what is happening in Mr. A is not the same thing that is happening in Mr. B. So we cannot group them to the same category. So that is why this model is not actually working so well for this kind of loan. So for the SBM also, the SBM also performed poorly by catching the default with 45.35%, just like it did with the isolation forest. So now, so looking at this, so we have the SG boost, we have the isolation forest, and we have the SVM. So that means that we cannot treat the default as an unsupervised model. Okay, so that is what this analysis is trying to tell us also. Okay, okay, so let me now take us to the last notebook, which is the Daleks. So this Daleks is just trying to explain. So as we know that it's just trying to explain why we are why are you selecting this kind of model? You know, in audits, when you are selecting a model for a financial sector, you need to tell us, aside telling the customer you are why you are defaulting the loan, then the overall bank itself, why are you not giving out this certain loan? So we need to explain all of this. And what can we use to explain this? We need to use the Daleks to actually explain why we are actually using that kind of model for our analysis. Okay, so looking at uh, looking at the Daleks, let me go down straight to the chart. Okay, I think I saved the images of the Daleks differently. However, so the Daleks is just trying to show us that this okay, so it's trying to show us the variable importance, which feature actually drive the model importance, right? So maybe I'll still go back and show us. So the key difference between the Daleks and the Sharp is just that why this borrower actually gets the score. So he's just trying to explain this is the reason why this borrower got this score, and this is the reason why we actually go with this model. Okay. um, okay, I think that's on the notebook, sir. Yeah, that will be all, sir. Thank you very much. App interface that's so I build a mini app interface whereby you can interact with the app such that you supply your information. So you supply the loan amounts, you supply all of those things, and the app is going to categorize the loan, whether this is an high risk or this is a low risk, or this is actually a medium risk, whether you should go ahead and give the loan out or you should not. So this is, let me open the live app here. So after that, and now after building the the app on Python, I now deployed it on Streamlight, so such that anyone can actually supply uh, their information, and the app is going to predict whether. So this is the app. So you give your age, right? Supply your annual income. You tell us whether you're single or married. You supply your loan amounts, your credit bureau score, right? The monthly repayments, the number of family that you have, your educational level, and the type of loan that you are trying to get, whether a revolving loan or not. Then the number of years you actually spent in your organizations, right? So do you own a car? Do you own a property? And if you actually submitted the necessary documents. So by the time you do that, then we click on predict default risk. So when you click on predict default risk, it's going to tell the loan officer whether this is actually a loan risk a low risk or a higher risk. So the probability of default of this person is 25.5%. So this is depending on the threshold that you've actually set for the organization. Then the loan to income ratio is 2.8, which is also fair. So like I said, this application presents a low default risk. It's just trying to explain what we have up here. Then this is now trying to tell why the loan will be approved or why the loan will not be approved. Okay, so because this person own a car, because so the reason why this might not be approved is because of the ID document age, right? Because of the annual income is actually lower than the loan amount and the credit bureau score. This red part is trying to tell us why there is going to be default if we give this person loan. But this blue part is explaining why this person will not default. That is reducing the default risk. Then the key risk factor are all of these. Then these places are just recommendation, credit recommendation, whether you should approve or disapprove. And lastly, we have the credit summary, more like a file of all of the information. Yeah. And the behavior, because this data was not built with Nigerian data, so the behavior could be kind of different from what is going to happen in other part of the country. So people actually make their comments that if I can actually put in the BVN parts, the NIN parts, and some other key information. But getting a Nigerian data set is actually a very key problem in Nigeria. Most banks will not want to release their credit data set because of data protection rights or
Mm.
because they're actually hiding one or two things that they don't want people out there to actually know all of these things. So getting those data sets would actually be a difficult task. So, but then we'll still keep trying and see how we can build a model across something like this.
Good.